Carl Sagan could not have predicted 2021, but he did see it coming. He wrote the following back in 1995, and we quote, "I have a foreboding of an America in my children's or grandchildren's time when the United States is a service and information economy, when nearly all the manufacturing industries have slipped away to other countries, when awesome technological powers are in the hands of a very few, and no one representing the public interest can even grasp the issues, when the people have lost the ability to set their own agendas or knowledgeably question those in authority, when, clutching our crystals and nervously consulting our horoscopes, our critical faculties in decline, unable to distinguish between what feels good and what's true, we slide almost without noticing back into superstition and darkness. The dumbing down of America is most evident in the slow decay of substantive content in the enormously influential media. The 30-second sound bites now down to 10 seconds or less. Lowest common denominator programming, credulous presentations on pseudoscience and superstition, but especially a kind of celebration of ignorance." Roll that around for a while. Those were among his final published words. He died 10 months later. Here we are 25 years later, realizing just what he was trying to tell us back.
Ashton Forbes, you know, that super jacked guy.
Malaysian 370, contact Ho Chi Minh 120.9. Good night. Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
Even as these grainy satellite images released today by the Chinese government.
Why shoot it down though if it's not hostile?
Our technologies permit us to manipulate time and space.
Why the Americans would?
They leave distance annihilated.
This country is very powerful. Far more powerful than people understand. We have weaponry that nobody has any idea what it is, and it is the most powerful weapons in the world. Not even close.
I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty. And to impress him, takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that, one way or another.
And here we go. Welcome everybody to the live stream, guys. It is a Wednesday, and oh boy, is there news going on tonight, guys. The whole live stream is technically dedicated to Nuno Loureiro. I don't know if that's how you say his last name. I'm just gonna kind of mumble his last name since I'm so bad at pronouncing people's last names. Loureiro. Anyway, tragic news, guys. Tragic news. There has been a number of shootings, assassinations, whatever you want to call them. And there was another one. Another one happened. A MIT, the director of the fusion program at MIT was gunned down in his apartment or in his condo, in his house, just the other night. And it's extremely suspicious. So we're going to dig into that. We're going to do what the only thing I could think of to kind of offer my condolences would be to watch one of his presentations. And I found a really good one online. Then we're going to watch and learn from him so that his legacy will be passed on to the next generation in one form or another. Before we dig into all of that, there's a couple other topics I want to discuss quickly tonight. So I already forgot my own topics here. Yikes, chat. Let me get my chat up here. Okay. First, war with Venezuela, chat. I don't know. I might be predicting the future here. People are saying it on the internet, and it seems to make sense. There was a big push. President Trump announced yesterday that there was a huge push that we've built up this huge force outside Venezuela, and the writing is pretty much on the wall. There's going to be military action in Venezuela. This isn't really that much of a surprise. I said before that I wouldn't be surprised if there was special forces action against the cartels in Venezuela. And it sounds like it might even be more than that. So for the people that are saying, oh, we're always getting our forever wars, okay, go ahead and take a lap. Go ahead and, do the I told you so's if you want. End of the day, I support the administration. I support whatever action they've chosen to do. I assume they've got a good reason to do what they're going to do. That makes me shill, then so be it. It is what it is. On that same front, there was another update. Another government update. Yeah, you guys just saw Lulu out there. Dan Bongino is stepping down from the FBI. Stepping down as the deputy director of the FBI effective next month. Now, why am I bringing this up? Well, he started following me a few months back. You might go back a few months and you will see, I think it was October, you will see that there was a live stream where I just happened to be checking my notifications and I see Dan Bongino's name show up as a follower. I go, whoa, that's weird. So, I don't know, non-zero chance that we get an invite to talk about teleporting airplanes and fusion technologies to Dan Bongino, who would at that point be a former deputy director of the FBI. In fact, I would have questions for him that I'd be curious to know about. So I might, if you see me simping for Dan Bongino, there you go. That's the reason why. Okay. And then the last thing is the new Spielberg movie. Now, can we watch trailers without getting copyright striked? How does that work, chat? I think we're going to just go for it. We're just going to go for it. My general impression of the new Spielberg movie that just dropped on the trailer is that it's just a bunch of garbage, honestly. Like I'm pretty disappointed in the level of slop that's basically been coming out these days. So here you go. Here's a clip. This is part of a clip. I guess I don't really know if it's trying to be like Signs or whatever this movie is trying to do here, but it's leaning heavily into like the alien kind of like presenting themselves. The idea that the aliens will present themselves and like, I don't know, do nefarious stuff to humanity that's real spooky. Like real spooky alien stuff's going to happen, chat. You're going to be really startled by all the alien stuff that's going on. So let's go ahead. Listen to this weird clip of Emily Blunt doing clicking sounds. Here we go. Where is it?
Let's today's
I'm letting go now.
No, Dad! Don't do it!
You'll lose the signal.
Oh, no, Signs is gonna copyright strike us. I'm not even gonna let that play. Last time I played that Signs clip, oh my god, it was an absolute nightmare. So Emily Blunt starts doing like African clicking noises, basically. She starts doing African clicking noises in the middle of the trailer, and oh, the libs, they love it, chat. They love it. I keep telling you, we have to keep the aliens safe. Everybody's got this shit backwards. They're thinking that we are got to be afraid of the aliens. No, no, no. Oh my God, no, chat. The aliens are afraid of us. The aliens are afraid that they're going to get deified, that someone's going to, tie up the aliens and sexually molest them. That's the real fear. We're the predators. We're the ones that are the pedos. We need to keep all the Kamala Harris voters specifically away from the aliens for as long as possible. Protect them. Keep the aliens safe, chat. So I don't know. I don't know what it is about this. I watched this trailer. And if I had watched this trailer 2 years ago, 3 years ago, before I'd seen the MH370 videos, it would have been the most amazing thing. I would have been the Redditor with the, look, it's just like the movies. Oh, that's how it's going to play out in the real world, right? I'd have been that guy. And now I don't even think I can watch that slop. I don't know if I can even watch it when it's free on a streaming service. And I already know what's going to happen. It's going to be the Arrival Part 2. Everyone's going to be going, this was the most important disclosure movie ever. If you are an experiencer, this movie is your Bible. This movie should win all of the Oscars. It should win Oscars in categories that it's not even nominated in. Like, that's what it's going to be. Get ready for it, chat. Write it down. I can see it coming. And we're at this point now where we might have just like spoiled it for ourselves. We can't just enjoy the simple things anymore. We just know too much. We've learned too much about aneutronic fusion, about plasma orbs flying around. We've learned too much about what the real capabilities are. Teleportation, free energy. And now when we watch this Marvel movie stuff and this Disney crap, all these DEI things, it just comes off as not being genuine. If anything, they downplay what is actually possible. Amazingly enough, they downplay what's actually possible. And that's why I feel more grounded in just talking about things that are real, like, plasma fusion scientists that are being assassinated in their homes. Because even if, in this case of the MIT director of the fusion program, by the way, chat, director of the largest academic fusion program in the entire world, gets gunned down in the back, walking through his own doorway into his own complex. Now, there's not a lot of possibilities here at play. People were asking me before the live stream, is your spider sense going off? Is your danger sense going off? Absolutely, it's going off, chat. Are you kidding me? What are the likely scenarios at play here? Guys don't just get gunned down in the back and happen to be fusion directors in their home. I want to tell you, this is real, by the way, what I'm about to tell you here. My brother, the one that was on those live streams that we did a couple times, he lived on that street. I won't say the exact number, but let's just say it's not a lot of numbers away from the number where that guy was assassinated. Like, that exact street that he was killed on. My brother lived at that back when he was in college. So it was a long time ago, but lived on that street. So I've been to that exact location multiple times. And it's not the kind of street where gangbangers are rolling down just shooting people on the side of the road. So what are the possibilities that what could have happened here? There's not a lot. It really gets narrowed down pretty quickly. Is it a random act of violence? Almost certainly not. Means it probably he was targeted. So was it targeted because an ex-lover was mad at him? Probably not. Doesn't strike me as the kind of guy that's unfaithful, that's prowling around in the middle of the night, Doesn't strike me as the kind of guy that was addicted to drugs that got down bad with his drug dealer, So it's like, what are the possibilities? Literally the director of the top academic fusion program in the entire country, and we're in the middle of fusion becoming publicly disclosed. I mean, fusion has always existed, and we've had it cracked, but we're actually right now watching it become publicly accepted and commercialized. In real time, we're watching it happen. Which is the biggest part that makes me suspicious about the whole assassination by him. And if you needed more, yes, I'm going full Candace Owens here on this, guys, by the way. Just recently, 9 Iranian scientists were assassinated in Iran by Mossad, which, is basically synonymous with the CIA. They were assassinated, 9 of them. 9 Iranian nuclear scientists were recently assassinated. So now you go, if they were looking for revenge, that would be pretty high on the target list for people to get revenge on. So I'm not necessarily saying Iran did it, although I have seen reports of people already claiming that Iran did it. I look at that as just kind of propaganda at the moment until there's some actual evidence to be thrown out there. But you can't rule it out. The circumstances of the situation are consistent with an assassination, a state-sponsored assassination. And he's a target that you would expect as well. That being said, I just feel the need to say, dear U.S. adversaries, look, I'm just a chill guy. I'm just a chill guy trying to understand aneutronic fusion, trying to solve a missing airplane that may or may not have been teleported away by some orbs. I've helped you guys out. I have helped you guys out, my adversaries. You have no reason. We have no ill will here. Kim Jong-il, Kim Jong-un, whichever one we're on at this point. So, let's just be chill with one another. That's all I'm saying. But I'm joking, of course. But to be honest with you guys, I'm not afraid of anything happening to me. But what I will say, the reason why I made that joke is that I'm going to pull up this presentation. We're going to watch this presentation by the man himself, the man of the hour. Rest in peace. And as I watched this presentation, I started to realize that I understand like 90% or more of the presentation. And I'm having an epiphany while I'm watching it, realizing like, wow, me personally, but this community in general is rising up the ranks in terms of our knowledge base when it comes to fusion. I mean, this was the number one guy in the country from the academic perspective. We don't know if he was a Black Project engineer, but he could have been. He could have been somebody that was in the JSONs. I doubt it, but he could have been. And our understanding is now basically on that level, getting pretty close to it. I'm not trying to say I'm as smart as this guy is, but we're getting pretty close to it. And so you start to realize, oh, wow, we're actually becoming a real threat. We're becoming a real threat in the knowledge that we have been absorbing, the knowledge that we have been amplifying out to the community. And I think the thing that was the biggest revelation were some of the key points that he mentions in this presentation. I'm going to say them right off the bat so that I make sure they get the justice they deserve. 2 key points that I want to address to you guys. Number 1, he talks about that we can't explain where the magnetic fields from the Earth and the magnetic fields from the sun come from. They should have dissipated away long ago, specifically the one in the Earth. If it was just a normal magnetic field that was primordial, meaning that it originated from when the solar system was created, it should have dissipated away long ago. And yet it didn't. It hasn't. In fact, not only has it not dissipated away, the magnetic field has remained relatively constant. We can tell because we can do like soil sample stuff, checking magnetic field lines. What does that mean? If you are MH370X, you know what it means. It means that there is some understanding of space-time, of the universe itself, that allows for more stability, specifically plasma stability, than what classical physics would allow for, would explain. That was the first major revelation because it tells me something about his scientific viewpoint of the universe. Is that Loureiro was looking out at the universe and he was going, wait, we see these things. We see these clues to how fusion will work in the universe. And this tells me this was not a guy that was an MSM brainwashed person. He was somebody that was thinking for himself. The other big thing that he mentions, what was it? Sorry, I took some notes here. Amplification of magnetic fields. He specifically calls this out in the presentation we're going to watch. I'm going to play the clip for you. Calls out that this term in the equations, when you're doing magnetohydrodynamics, implies an amplification factor of the magnetic field strength. And this is the very thing that I was trying to reconcile with Salvatore Pais. And Salvatore Pais was saying we can achieve this magnetic field amplification, energy amplification. But if we look at our temperature, that Maxwell-Boltzmann distributions, that says that, well, as we increase frequency, we get this cutoff all of a sudden. But this is saying when we look at this equation, we see there is no cutoff there. So how do we reconcile this idea of energy amplification? And where is that energy coming from? If we're amplifying energy, from where? From what? And the answer is the space-time lattice, the 0-point energy. This is what Salvatore Pais is getting at. So now I'm ready to say that the answer to fusion is we are going to find out something miraculous about fusion. What we're going to find out is that when we do fusion and we compare it to the models, the chemistry models of the energy that's coming out, it's not going to add up. There's going to be an extra term. There's going to be an extra term. And we can already predict this extra term because there are relativistic effects that we are generally ignoring when we're doing our models. When we accelerate things towards the speed of light, our physical perception of what's happening changes. This is exactly what Einstein predicted. So those are the two main things, but there are more takeaways from this. So just imagine, like, we're listening now and we're learning from somebody who's now deceased, but was the premier expert at that's if not number one, number two top colleges in the entire country, possibly the world, at the leading academic fusion center in the world, giving us his insight to how fusion works and the significance of fusion and what we should be thinking about when we're thinking about how to do fusion and how to do it successfully. Okay. Now, before we get to that, I do want to play this clip. One more clip I want to play for you guys here that I had queued up, ready to go. And this, I just think this is so relevant. It's kind of a long, it's only 2 minutes, actually. Eugene Malov. So, Dr. Loureiro, he is not even the first MIT scientist related to fusion to be murdered. Eugene Malov blew the whistle on the cold fusion cover-up in 1989. And he was actually a finalist for a Pulitzer Prize, I found out. Eugene Malov was a finalist for a Pulitzer Prize related to his investigative work into the cold fusion cover-up in the 90s. And in 2004, 15 years after he blows the whistle on MIT, blows the whistle on the cold fusion cover-up, he's mysteriously found brutally murdered in his home, beaten to death. I read about the murder, like his neck was crushed. They crushed his neck and they beat him in his face with a blunt instrument multiple times. That's giving you the PG-13 rated version. And the rest I'm going to tell you is true because I couldn't even believe this, because people say, well, why do you think this is a cover-up? The reality is they arrested 2 people for Eugene Malov's death, and then they ended up releasing them. They ended up realizing they had nothing to do with his death. So this is 2004. He's murdered. Case goes cold. 6 years later, 2010, they arrest 2 different people for his death and his murder. The story goes that they were neighbors or something that broke into his house over some debt or something like that and stomped him to death in his own home. So I don't know. I don't know what the truth of the Eugene Malov situation is. All I know is that whole story, that whole case is as suspicious as you could get. You thought you had 2 random people for his death and they turned out to be completely unrelated. Then 6 years later, you find 2 other random people and decided those people were related. People don't generally get stomped to death in their own home. They don't get shot to death in the back in their own home either. And it turns out they're always seemingly connected to, not always, but in some cases at least, connected to fusion research, neutronic fusion research. So, and before you ask me, because I just threw that out there is a reference to neutronic fusion in this video that we're going to end up watching. That I don't know how much in-depth research he had done into neutronic fusion, but I do know he was aware of it. Anybody that knows about fusion is going to know about neutronic fusion fuels because it's basically like the holy grail. It's just that a lot of people imagine it being too far out of reach, and so they don't really talk about it that much. So before we get to that, though, I want to play this video because this is Eugene Malov. This is him right here talking about the cold fusion cover-up. And this is important to listen to. I want you to make sure you're listening very carefully because he's explaining the reasons how the cover-up happened, why it happened, and how they're able to be successful. Because I think a lot of people struggle with this idea of how could you cover up science? How could you cover up physics? How could you cover up an understanding of reality? The short answer is brainwashing, propaganda, and brainwashing. The longer answer is humans are not good people. Humans are not good. Here we go.
That was a threat to the scientific establishment. The threat of it even being implied as real and having monies, shall we say, being diverted from their favored programs, and that was a threat. It was real. Overwhelmingly compelling, as I said, in Fire from Ice. It was real. Now it's 100% certain. In fact, what Pons and Fleischmann found was only the tip of an iceberg. But within weeks, the hot fusion people were going into action behind closed doors to disprove them. The difference between July 10th and 13th was dramatic. The raw data, excess heat. But then on the 13th, it was shifted completely. It was altered. They did some standard averaging, which was appropriate, that is in time blocks, but the level of the signal had been utterly changed. It looked like monkey business to me at the time, and it has turned out to be exactly that. Scientific paper done under Department of Energy contract that had altered data, and that data is scientific fraud as far as I'm concerned. It was represented as a negative result when it was positive. The representation of the altered data as a negative was clear fraud.
So if you're not familiar with what he's talking about here, he's actually kind of talking about two different things, but the big one is that when cold fusion was proven to be real, I say it was proven to be real because by my standard it says it was. By the scientific standard, it was proven to be real. Is that they came out, they came out and they went straight to the media as opposed to going, Pons and Fleischmann did, as opposed to going through the peer review process. And they said, here you go, here's how we did it. And everybody says, okay, we're going to replicate it. And we're going to see, does this work or not? And so they did. They replicated it. And they did replicate it, and it worked. There were 60 replications. 60 replications. And it got so overwhelming that the DOE had to step in, and the DOE used their partners like MIT, because the DOE had a strong relationship with them, and they developed a tribunal of the top physics experts, probably several people who were on the JSON group. And they went lab by lab, and they debunked. They started at the top ones and just started debunking the most significant ones. Claim that one of these was because of high voltage on the weekend. This is, by the way, that's very real. They did say that. They just basically made up a bunch of plausible explanations for why they were seeing these provable experimental results. And then they forced them to retract those papers. The pressure of the DOE coming to your site and saying that there are flaws in your experimentation causes you to retract your papers. And so cold fusion went away. And so the DOE not only did that, but they did their own experiments, their own replications with MIT. And this is where Eugene Malov is saying that they cooked the books. They did some normalization, but they probably made the error bars look smaller, so they made it look like the excess heat wasn't really there. You know, it's just manipulating things with statistics. Pretty simple to do. So that's what Eugene Malov's central claim was. And then they used their study. They said, oh, look, we did one and it didn't find any excess heat. And we debunked all these other people. Therefore, cold fusion is fake and gay, and anybody that talks about it is also fake and gay, and they don't get any money from the government. That's pretty much what they said and what they did.
We know for a fact today that the cold fusion, low energy nuclear reactions are real. In a few instances, I can say there are clearly over unity electromagnetic devices, things that produce more electrical energy out than in. Electromagnetic theory will require radical revision. The only way of approving any patent that resembles cold fusion is to eliminate the words cold fusion or anything like it. They no longer look at the data. Of course, they never really looked at the data. They had a bad frame of reference.
I want to point that out too. This is something I've independently figured out, and just my own thing is that they don't actually even look at the data. Like, imagine there's 60 different sites are showing positive results. I mean, how could you possibly debunk that? The answer is they don't look at the data and they don't look what you actually did. They just come in and they say, this isn't possible. Therefore, we're going to come up with a plausible explanation for why it didn't really happen. And if this just makes you go crazy, welcome to the Matrix. This is the Matrix. This is how they suppress it. This is how we brainwash ourselves. In fact, we do it to ourselves to some degree. When I look at people commenting about cold fusion, I see people in the replies who were born after the cold fusion fiasco that are going, cold fusion is fake. And you're like, you don't even know what cold fusion means. You probably don't even know who the names of the people were who brought cold fusion to the foreground. But they know it's fake. They know it's fake. And that's the key. Nobody even looks at it. How did I learn this firsthand? Pretty simple. I built a magnetic motor device. Or let's just say I had one built, and I challenged major YouTuber electrical engineers who believed that free energy was not possible to review it, to test it, to come and see it for themselves. Did any of them accept the challenge? No. Of course they didn't. Not one accepted the challenge. None of them. They all came up with excuses for why they wouldn't do it. They claimed that it wasn't possible, therefore there's no reason to waste their time. It's actually, so when people say if it was real, somebody would do it. Somebody would prove it. They have done that many times. That's not the standard of evidence. That's just the standard of evidence we imagine in an idealistic version of the reality that we live in. In the real world that we live in, people will only believe something when the government comes out, when their authority comes out and tells them this is reality. That's how they were able to keep it hidden from us for so long.
To begin with, they said it must work like hot fusion. Well, this was in a solid state. It's just like saying the equivalent of demanding that cold fusion works like hot fusion is like saying a transistor works like a radio tube. There must be this product or this radiation or we're not going to believe it. The Wright brothers airplane flew, and there was very much controversy about that from 1903 to 1908. One prominent critic who said it would never fly, it never would be real, could never be done. This one is particularly intense because of the threat to academic wisdom. There's nothing worse, I found, than suggesting to academic physicists in particular, and academics in general, that they are not only wrong, but disastrously wrong, catastrophically wrong. And that once they are proved and shown in public to be the fools that they are and the bad actors that they are, there's possibly going to be some punishment for them.
There you go. He hits the nail right on the head there at the end. He says they're afraid, right? The reason why they don't want to review any of this, so they don't want to look at the evidence, is they're afraid of being wrong. They're afraid that if they were wrong, what are the consequences going to be? What does it mean for the people that won the Nobel Prize? What does it mean? I'm not going to name names. I'm going to name names. What does it mean for Brian Keating, who's out here just HJ and all these physicists off who he thinks are the smartest people in the world because they won a Nobel Prize? when it turns out the Nobel Prize is basically just something we give away to appease people in the public sector. What are those people going to say when they find out their whole life's work was one big joke and the joke was on them the whole time? How is that going to play out for people? Right? This is why I think the people that have been hiding this technology, I think they're waiting the clock out. They're like, I want to die before the public realizes what's been happening, because some of these people are going to be really upset and people are going to be out for blood. People are going to be out for blood because you pretty much were holding back all of human civilization. And you got to try to justify to us that you were doing it for moral, just causes and not for your own greedy self-interest. Good luck with that one. Good luck. Okay. I don't want to waste any more time. Let's get right to the science, right to the physics here. So that was Eugene Malov. Let me go ahead and show a couple of things that I found related to our subject of the hour here. Subject of the day. Is that right? Yeah. Okay. This is it. Okay. So one thing I did find was Nuno's MIT page, because I wanted to see what has he actually been working on. What research has this guy been working on? And I mean, he has won several awards. And when I saw his research interest, this is what made me really want to know about him, because right off the bat, you see magnetic reconnection. Wow. What is one of the things that I've spoken about related to the MH370 orbs, or let's just say, I'm not going to be coy. Magnetic reconnection is one of the things that I've been speaking about, is that when the orbs are converging on the plane, I'm pretty sure that what the trigger mechanism is a magnetic reconnection moment, when the magnetic fields of the three orbs converge into one and cause a magnetic reconnection moment. And when you read about why this is significant, is the idea that the magnetic reconnection releases energy, releases a huge amount of energy. What if the magnetic reconnection moment in this case releases this energy, but like a vortex that just sucks the plane to a different location? That's the theory that I've got going. So here you go. Magnetic reconnection. Ubiquitous phenomenon in nature. Solar flares, magnetic substorms, and a sawtooth of tearing instabilities in tokamaks are just a few examples of fascinating effects where reconnection plays a key role. One of my research interests is understanding the instability of reconnection site to the formation of multiple magnetic islands or plasmoids. Hold up. Well, what do we have here? Plasmoids, chat. Plasmoids right there. So there, he's got his papers. We're not going to look through his papers tonight, although this is interesting. Magnetic reconnection is fundamentally an energy conservation mechanism. Energy stored in the magnetic field is channeled into particle acceleration and heating. Those are extremely significant effects when it comes to fusion. So we can understand now that obviously he was very interested in the phenomenon that allow fusion to happen, allow it to exist. And he also specialized in confinement and transport in fusion plasmas. The ability to keep a fusion temperature plasma well confined is critical to the success of the fusion program. This is often impaired by turbulence and or macroscopic instabilities. So he developed some code here. This is 2016. A complementary aspect of my research is the confinement of very energetic fusion-borne alpha particles, which are critical to keep the plasma hot and ensure the fusion can be self-sustained. Alpha can resonate with a particular set of plasma waves known as alphin waves, leading to their destabilization and ensuring alpha transport away from the plasma core. Now, this is really interesting because this is about how you actually control the motion of the electrons versus the ions in your plasma. And in theory, what you're doing is you're like, okay, if I have this plasma and it's just going, how do I control that and keep it going for as long as possible so it doesn't fall apart? What else did I find on him? This is another MIT page for him. I think this actually found his research from a link through here as well. Theory and computational simulation of nonlinear plasma dynamics. Wow. Use a combination of analytical theory and state-of-the-art simulations to investigate several topics in nonlinear plasma dynamics, particularly magnetic reconnection, turbulence, and instabilities. He also had an active interest in novel computational techniques for plasma simulation. He won a bunch of awards. There you go. Now let's just get to it. Let's listen to the man himself. Here is a presentation. I don't know. I think somebody in the Discord found this. I do want to point out when I hit refresh on here, watch how many more views this has since last night. I watched this last night. It had 893 views last night. And I shared it on social media last night. It's got 11,000 now. It's got 11,000 views now. So I shared this last night and I see people posting about it. One thing I want to say is I saw somebody that I don't think I'm friends with, that I don't think I even like. The magnetic pole reversal guys or whatever, trying to say that this means the guy believed in the ether and that Einstein was wrong. That's not right. That's not true. Einstein was correct. And I think a lot of people just don't understand how Einstein was correct. The MH370 videos prove Einstein was correct. They prove he was correct. They prove relativity is correct. Relativity is actually what makes all of this possible. It turns out that when you say we're all in our own little bubble, our own little frame of reference, that's what breaks conservation as we think of it. That's what makes us able to create an asymmetrical system where now cold flows to hot instead of hot flows to cold. That's the basis that allows it to become possible. So I do think Tesla was right, but I think Einstein was right as well. And it doesn't mean that this guy didn't believe in the ether. He could have believed in the ether, but that's not what he's really necessarily saying in his presentation here. So I did want to say that because I don't like when people are like trying to use people's deaths and their views for their own agendas. Though I guess you could argue that that's what I'm doing. So in this case, I don't think he would mind. I think he wouldn't mind if the agenda is getting people to understand fusion research. So here we go. So we already know what plasma is. I'm going to skip through some of the intro stuff, but it's kind of amazing that we're at a point now in our knowledge base where we can skip through like 15 minutes of a PhD MIT director of fusion because we already know. What is plasma? Plasma is when you take an atom, like a hydrogen atom, you shoot some energy at it like a laser, and that makes the electron orbital, the electron rip away from the ion. Now you've got a separated electron and an ion. Now you've got a plasma. Keep them separated. Keep them separated and you've got a plasma. And now we think of this plasma that we've created like a soup. Like a soup. And this is, I'm kind of stealing his thunder right here. So let's listen to the man of the hour. Here we go. Rest in peace. Rest in peace, by the way. Heaven has a new engineering goat, chat. When heaven needs to orb Satan in hell, we've got another fusion expert up there, another quiet fusion goat up there helping him out.
Highly energetic electrons that, in extreme cases can actually fry satellites. And, that's a problem for communications on Earth. You may have heard of
okay, here we go.
Why plasma physics matters. So I said this already. It's interesting per se as an intellectual frontier of theoretical physics. And sort of, by the way, the question that often arises is this. I sometimes explain to colleagues that a lot of plasma physics is pre-relativistic and pre-quantum, and they sort of stare at me in disbelief and think, how can that be any interesting? And well, it's interesting in the sense that out of equilibrium statistical electrodynamics is not a solved field by any means. And so that alone, so Maxwell plus Boltzmann, leads to enormous complexity, and that's quite enough to keep a lot of us busy. So I'm not over.
So he just said something really big there. He said that plasma physics predates quantum mechanics. And he says, when he talks about Maxwell Boltzmann, he says, this gets really complicated. This is the thing. Why have we been studying plasma physics in all our labs? Why is fusion always 30 years off? Because it's really, really complicated. Because what we're trying to do is we're trying to model the motion of individual particles in a giant soup of particles. We're trying to model that and figure that out. It turns out quantum mechanics helps out a lot from this perspective. Helps out a lot.
We're stating it when I say that it's an open intellectual frontier of theoretical physics. But in terms of sort of scientific and engineering questions, you may have heard of fusion as an alternative clean energy source, so much so that the National Academy of Engineering here in the US has chosen fusion as one of the grand challenges for engineering in the 21st century. And I'll talk more about this. Fusion at its heart, whether it is successful or not, depends on how much we can control the plasma and predict and understand its nonlinear dynamics. So that's quite a challenge.
So he just said it right there. I'm not going to harp on it too much, but he said the key to fusion is controlling and understanding the movement of the plasma. So now we can also understand that when we talk about these simulations, why we need these super powerful computers to do the modeling, because the modeling and the math that we're doing here is really complicated. Because it's like, what do we know? We know that space-time tells matter how to move and matter tells space-time how to curve. Well, okay, so you're saying that space is moving the matter, telling us where to move, but the matter is also bending the space-time at the same time. So it's kind of feedback loop on itself. So you have to model that with a supercomputer, but you have to model it over some big region of space and how that's all going to work out. It's very complicated.
And then there's a lot of applications in astrophysics. And one of the ones that I will talk about a little bit is the origin of magnetic fields that pervade the universe. And that ties into the magnetogenesis problem and the dynamo problem, meaning the amplification of magnetic fields via plasma motions. Things I won't talk about so much are origin of cosmic rays, which are thought to be accelerated by plasma processes throughout the universe, black hole emission and jets, and a lot of other things like neutron star collisions, magnetars, etc. Many astrophysics illustration here is actually a simulation done by a high school student that was interning in my group. And this is just to show you the sort of complexity of electron trajectories that you can get in a plasma if you have a magnetic field that you impose that's varying sinusoidally as a function of time. Okay, so this picture here is, imagine that you give these electrons a magnetic field that you prescribe. This magnetic field varies as a function of time at some frequency, and you ask, what are going to be the trajectories of these electrons? And this is what you get. You see the electrons with random velocities initially, and you get this sort of behavior. As an illustration, I think it makes it quite clear that even sort of prescribed simple magnetic fields give rise to a lot of complexity. And magnetic.
What is he saying? His long-winded way, he's saying that this gives rise, there's a lot of complexity in our plasma. Since the plasma is producing its own electromagnetic fields, this is going to be extremely complicated. Is that even if you take the most simple situation, these electrons are bouncing in every single different direction. So how are we going to ever model this? We would have to understand the nature of space-time itself in order to model this. Hold up. Does anybody out there know the nature of space-time? Uh-oh. So you're saying that if we understand the nature of space-time, we might be able to accurately model how all of these particles are going to move around everywhere? Yes. And we do have an understanding of space-time. What is our understanding of space-time? Well, 0-point energy. 0-point energy is our understanding of space-time, an extra dimension of energy that's all around us all the time, that allows for entanglement to exist between 2 points. If we have that, if we understand that, and let's just say hypothetically that the connection is vortex motion through the ether, right? Alternating vortex flow. If we understood that, then in theory, we should be able to model plasma extremely accurately and even predict where the particles are going to move at every given moment. That's pretty much what we would need based on what he's saying right here to solve fusion. The good news is, I think we've got that.
fields in a plasma when they are evolved
A
self-consistent.
little bit.
And here's Boltzmann equation, if you wish, where the acceleration is given by the Lorentz force, the electric field plus a magnetic field acting on the particles that are at position r with velocity v. Okay? So how do you solve this self-consistently? Well, you do it as follows. You say, I'm going to solve this equation, but I need electric fields and magnetic fields. Wonderful. So I know Maxwell's equations. Here they are. And by the way, they are written here in CGS units because we are strong believers in the fact that the electric field and magnetic field should have the same units. So we use CGS tendentially. So there you are. So that's it. So that's Maxwell. And then you say, well, but Maxwell depends on charge density and depends on current density. So how can I compute those? Well, you do that because charge density is the sum over all species of density times charge. And the density is just the integral over velocity space of the distribution function.
So if you're getting lost here, my wine moms, Ashton's Orby OnlyFans wine moms who are out there watching, who are going, Ashton, I'm already 6 Franzias deep. I can't keep up with the math. I got you. Don't worry. That's why I'm here. That's why Ashton 4 Orbs is here with my big orbs. What he's basically saying is we know the math to solve the plasma motion. We know it. We just apply F equals ma. Just apply normal basic physics. An object in motion stays in motion. Just apply normal basic physics, electromagnetic equations, Maxwell's electromagnetic equations, the 4 simplified equations. That's it right there. He's saying just apply these equations. We're just going to apply these equations to plasma, and then we'll know how plasma moves, right? Simple. That's his thought. That's what he's getting at here. Now, let me skip ahead a little bit.
Of course, this is a fully nonlinear system because to compute F, I need the electric and magnetic fields, but to compute the electric and magnetic fields, I need to know F, right? So it's fully nonlinear. And F itself is a 6D object plus time. And that's incredibly unpleasant, of course. You are not going to make a lot of progress trying to solve this analytically. It is sort of very difficult. It took someone like Landau himself to solve the linear version of this problem and therefore derive what is known as Landau damping in plasmas. And it took a Fields medalist, Cédric Villani, recently, a mathematician, to show some interesting effects about the long-term behavior of the solutions to these equations. So, I'm not just naming.
So some people, so basically he's just name dropping. No, I'm just kidding. He makes a joke about how he's not just name dropping. Basically, some super smart people spent probably like 70 years solving these equations to figure out how the plasma is going to move around. Right? They're like, okay, we're going to treat it like a gas, and now the particles are moving around, and now we're going to do these complex electromagnetic equations, see how the particles move around, and then what happened? Some smart dude came in and just invalidated everything. Some smart dude rolls up and goes, you know what? This is stupid. He's like, we can just treat the plasma like a liquid. Why are we modeling the plasma like a gas at all? He's like, in fact, if the plasma is dense enough, then you can just treat it like a liquid. And then you can just use fluid dynamics, fluid mechanics to understand how it's going to work, how it's going to move. Boom. Mind blown. All the big brains. Now, they just look like a stupid bitch. Makes all the scientists before who thought they were so smart look like a stupid bitch, chat. Happens so often in science. They think they're smart. They think they know everything. And then, boom. Science is a bitch sometimes, chat. It's true.
Dropping, I'm saying this to response.
Okay, so wait, hold on.
Interacting with each other, but I don't need to think about these particles. Maybe they're colliding enough, right? They collide all the time, and therefore they have a fluid-like character. The flow of this object, this plasma, is like water, except of course it now responds to the Lorentz force. And so if you adopt that, so assuming that there's enough collisions, the distribution function is approximately Maxwellian, you'd write equations like this, where rho is mass density, so this thing is like a continuity equation. This thing here is actually just F equals ma, right? So this is the momentum equation, where the forces acting on your fluid are pressure gradient, viscosity, Lorentz force. This is the acceleration. And then you need a diabatic equation of states, an equation for pressure. Again, you need to know the magnetic field. So you couple that with what's left of Maxwell's equations. And these are called the magnetohydrodynamic equations. They're hydrodynamics, but now there's a magnetic field, so you refer to this as magnetohydrodynamics. And the first person to actually, I've been lecturing online for over a year now, and it's still difficult to get things right. Okay,
so there you go. Magnetohydrodynamics. He's got Hans Alfven right there. Hans Alfven on the bottom right corner. He says this is known as magnetohydrodynamics. So he says if we've got this dense plasma, we can treat it like a liquid. This simplifies the equations. Now we have a better basis for understanding our motion of our plasma. Now, at this point, in the back of your mind, you should be wondering, Ashton, haven't they known about this for like a long time? Like, isn't that photo of Hans Alfven in black and white from 1970? So why haven't they figured it out? What's the deal here? What's going on? And this is where I say, yeah. How do you think they figured out the fusion bomb in 1960, but we don't have fusion energy here today? Something's not adding up. Something's not right. All this physics has been known since the 70s or before. I mean, heck, Julian Schwinger and Richard Feynman, I think they won in 1976, right? So this stuff is ancient history when it comes to science. And yet, practically no commercial value from this fusion research that we have seen. Something isn't adding up here.
This is Alfvén, who was the person to coin this term, magnetohydrodynamics, and to first use these equations to derive a type of waves that is characteristic of plasma called Alfvén waves. Waves, disturbances in the magnetic field that propagate along the magnetic field. And just the fact that these are talking about quantities that you can measure and that you have a lot of intuition about. And also, oftentimes, well.
And I do have to point out here that we might be in a unique position. We might be in a unique position because I think that unless you're somebody that works directly with experimental plasma research, the idea of plasma being treated like a liquid really doesn't make any sense. I mean, yes, you can conceptualize it, but you're like, why would I treat it like a liquid? But when you see it for yourself, when you see a plasma orb, solid plasma orb floating around in the sky at hundreds of miles an hour, you look at that, you go, wait a minute, there's some physics going on there that doesn't seem conventional, doesn't seem intuitive from my perspective. That's where I think that this is like why it's so easy for me and for us in general to identify the people that know about the physics, to identify the real science that is being suppressed, the real secrets. Because we've seen that. We go, oh, we've seen the plasma orb, and we can see how stable it can be. So we know what we should be looking for. We're looking for people talking about plasma stability, magnetohydrodynamics, people talking about ways that they can see abnormal stability, excess energy production, amplification of energy fields. And sure enough, we're seeing it here.
Not often, but always.
Okay, so let's skip ahead a little bit.
Break of angular momentum conservation was viscosity, because viscosity is extremely small in many of these accretion disks.
Oh, I might have skipped. I think that was important. Hold on.
You see that these equations capture turbulence in this accretion disk, and that turbulence is why matter in the accretion disk accretes much faster to the central object than it would if the only thing causing your break of angular momentum conservation was viscosity, because viscosity is extremely small in many of these accretion disks. Awesome. So now that I think I've set the stage, I'm looking for a watch.
Okay. What do I see on my screen? What does my eye spy? What do I spy with my little eye on the screen here? I see deuterium helium-3 fusion. So right off the bat here, I can tell he's going to start talking about aneutronic fusion. I can see it right here on the screen. He's showing the various curves here for the cross sections. These are the cross section curves for the optimal temperatures that you want to run each individual fusion fuel at. Chat, what the hell is wrong with me? How do I even know that? How do I even know that? Sometimes I actually wonder if I'm even if I'm an alien. Sometimes I think I'm an alien. I'm not even a human. That I'm getting alien downloads, and then I'm just here regurgitating what the aliens are telling me. Because somehow I understand fusion curves and things like that I never would have in a million years would have thought I understood. Anyway, so here we go. Let's go.
So let me tell you a little bit about fusion. So the sun shines because fusion happens in the core of the sun, right? And we've been trying to do that on Earth for quite some time now. Our problem is, of course, that we don't have the kind of gravitational pull that the sun has, right? So you can't very well just come up with an experiment in the lab where you're going to confine a plasma gravitationally by just having, some source of gravity there, right? So we're trying to do it with magnetic fields instead. And it all relies on taking some gas, right, and heating it up so that two nuclei can overcome their mutual repulsion, overcome the Coulomb barrier, and fuse. And in this particular case, for example, deuterium plus tritium, you get out an alpha particle, so helium plus a neutron. And the reason this fusion reaction in particular is the one that we most often consider has to do with cross section and the shape of the cross section as a function of energy. And if you think that it's difficult to heat something to very high temperatures, what you seek is the reaction that's going to maximize cross section at the smallest possible temperature. Right? So you could be doing it with helium-3, or you could be doing it with deuterium, but the reaction that has the highest cross section at the lowest temperature happens to be deuterium tritium. And so that's why we sort of do it. And the whole idea is very, very simple. This reaction produces an alpha particle with 3.5 MeV energy. It produces a neutron with 14 MeV energy. The neutron, of course, doesn't respond to electric fields or magnetic fields, so it comes out, and you use it presumably to activate some sort of heat cycle. And the helium stays confined, and you hope to use the energy from the helium to keep your plasma hot.
So there you go. He just explained the basis for hot fusion right there. First thing he says is, why are we going through deuterium tritium when we have a neutronic fusion? Well, temperature is way lower. Requires way lower temperature. And right here, he's actually explaining magnetic confinement fusion. There is a slight difference between magnetic confinement fusion and inertial confinement fusion, though they both have similar principles. So magnetic confinement fusion, we're trying to force these two particles together to overcome this Coulomb barrier. That they want to repel each other, but we want to force them to come together. So what he's saying here is that we need this high temperature. We need this high, I wouldn't really call it temperature. I think a better way to describe is we need this higher energy level. Temperature, heat is energy. And my view is that all energy is just energy. Electrical energy is obviously related to heat energy. They're all just energy. So for me, I think the secret we're going to find is there's non-radiative energy from the vacuum of space-time that can be used to either lower the Coulomb barrier or used in effect to cause attraction between our particles that can allow for that cross-section we're seeing here to happen at much lower temperatures. Much lower temperatures. And this is where cold fusion comes into play. So for those of you wondering, how does cold fusion functionally play into the hot fusion science? This is it right here. What cold fusion is saying is that we don't need these high temperatures to achieve fusion. And that, in my opinion, the theory that covers cold fusion the best is resonance, the resonance model. If I vibrate two molecules right next to each other, right? Imagine two molecules are right next to each other, locked in place, and I start vibrating them. In theory, this might be able to overcome the Coulomb barrier without this huge temperature. And this would be abusing general relativity. Relativistic effects are being abused in this situation because from the perspective of the things vibrating, Imagine seeing something moving away from you at super high speed and coming back at you at super high speed. This is called a relativistic effect. And so we can abuse these relativistic effects even on these small scales. What we're going to find out from this presentation is that these relativistic effects are discounted. When it comes to plasma fusion, when it comes to hot fusion, they completely discount these relativistic effects. They say that we are doing our plasma science much lower than the speed of light. Therefore, those relativistic effects don't apply and don't matter. Well, I mean, that's essentially like taking away half the recipe and then wondering why your pizza didn't come out right. Like, hey, the pizza sauce doesn't matter, chat. Don't worry about the tomato sauce. We don't need any of that. Just put some cheese on some bread. Maybe throw a couple slices of pepperoni on there. Put it in the oven. You can have some cheese on your pizza, on your bread. Cheese bread. Yum. So that's the secret. If you want to know like how and the why and the nuance, well, you're watching the right stream tonight. I'm giving it to you straight. Here we go.
Sustaining reaction.
Okay, let's learn about
this. Is not easy to
fusion.
do. So ask yourself, how do I confine a gas of electrons and ions? So you try to put it in some container. Let's say it's some sort of cylinder. And of course, if you random is in random direction, right? So they'll there and eventually hit the walls of your device and recombine there, and you're out of plasma. So one way to do it is just say, well, let me have a magnetic field threading a cylinder, and I know that if I do that, the particles can move freely along the magnetic field, but perpendicular to the magnetic field, they have to go in normal gyrations, and so they're confined, at least perpendicular to the magnetic field.
Okay, this is huge, guys. This is absolutely happening in the orbs and the MH370 videos. You ask yourself, number one, how do you confine the particles? That answer is simple. And the funny part is when I was watching this whole presentation, the whole time I'm sitting there in the back of my mind thinking about Charles Chase from Lockheed Martin. And I'm thinking that these guys were answering all these questions. You can even imagine the Lockheed Martin guys watching some presentation like this going, okay, we got to solve the kink instability. Okay, let's get that solved. Okay, we got to make the particles all get stuck and confined. Okay, well, you know how we can do that? Magnetic fields. We'll get the particles confined by the magnetic fields themselves because the particles will not be able to fight against the magnetic field lines. If my magnetic field line is curving like this, my particle can't move perpendicular. In fact, my particle can't move in any direction other than along the magnetic field line. It must follow the magnetic field line. That's what this image is showing right here. This image is showing that we can confine the particles by manipulating our magnetic fields, and then the particles will naturally follow them. And what does that mean? That means we no longer need a cage. We don't need a metal cage for our fusion reactor anymore because the cage is the magnetic fields themselves. This is the beginning, the precursor towards an exotic vacuum object. Because once you've understood that the magnetic fields themselves can be the confinement of the plasma, your next logical question would be, why do I need anything inside my plasma ball at all? Can't I just spin up like a smoke ring of plasma and just have it go? Yeah, you can. And the stability will be much longer than what classical physics will predict. But if you want a plasma ball that's a permanent plasma ball, one that can be controlled actively, you're going to need at least some equipment on the inside of it. And I'm not here to gatekeep what kind of plasma balls exist in the world. We can probably build anything that you want, anything that your mind could imagine. So magnetic field, magnetic confinement is all about using the magnetic fields themselves. And look how he's got the electrons here corkscrewing around, right? When we think of the motion of the electrons, we shouldn't think of it as a straight line. They're corkscrewing around in a vortex motion. What is large can be made small, scale invariance. Truly, the more I've researched the physics, the more convinced I am that scale invariance is the answer. When we look at the atoms, they are going to look like the solar system. the Copenhagen interpretation and the way they took quantum mechanics, they said, no, you can't know anything. Nothing is real. I disagree. I think that everything is real. Everything is deterministic. We can know things. That's what I think the real secret of quantum mechanics is. And that opens the door to teleportation. Because then to create teleportation, we would know exactly where the plane is going to show up on the other side. No doubt, no probability, 100% certainty we know. Okay, sorry, I started going on one of my classic rants. Here we go.
If I want them also to be confined along the magnetic field, all I have to do is turn the cylinder into a donut, right? Torus. And that's the whole idea behind sort of the most advanced schemes in magnetic confinement fusion. And we call this a tokamak. Here's the most recent conception of one in a model that MIT is proposing here called Spark. You're seeing a cross section, of course. This thing is a toroidal chamber that's been cut here in the drawing so that you can see the glow of the plasma inside. This is just a cartoon, of course. This is not a real experiment. We're building it now, hoping to have it working in 2025. And so the gas is here, you heat it up, fusion reactions happen here, neutrons escape, and you get energy. It's a beautiful thing if we can make it work. But this is not easy. And one of the reasons it isn't easy is very easy to understand, okay? So let me go back to this cross section here, and let me call your attention to this number, 100 keV. 100 keV is around 100 million degrees centigrade. So that's hotter than the surface of the sun, okay? The sun doesn't have to worry about this, but we do because we want to maximize fusion reactions. And so we want to operate at very high temperatures. And so that means that on this drawing, there's going to be a plasma here, which at its center is sort of at, maybe 20 keV, okay? So 100 million degrees Celsius.
This is important.
But over here, well, there's going to be a material surface here, right? And materials are going to be at room temperature. So the temperature gradient from here to here is probably the largest temperature gradient in the entire solar system. Okay?
Wow. When he said that, and I listened to this, I went, holy crap. I just kept thinking about the orbs in the MH370 videos. Realize the orbs in the MH370 videos are fusion reactors. That means at the center of those orbs, that we are looking at extremely high temperatures. Even in cold fusion, those temperatures are still going to be really, really, really hot. What that means is, just like he said right there, the temperature gradient. The gradient is the difference in temperature between the center of the orb where the fusion's happening and the edge of the orb where we can see the field in the videos. We can see the field of the edge of the orb. That's the highest temperature gradient in the entire solar system. The difference between the temperature at the center of that orb and the edge of that orb is a bigger temperature gradient than anywhere in the entire solar system, even the sun itself. How insane is that? How cool is that, though, too, at the same time? And now we look at it and we go, man, that heat signature of those orbs is probably like a fingerprint that basically says exactly who made that. Because however they designed that structure on the inside of that plasma orb is literally producing that exact configuration with the bubble, with the orange slice heat signature in it, with the axial jets of the reverse field configuration. Like somebody's probably like sweating bullets because they're like, someone's going to figure out that I'm the person that made that, Woo. Oh boy.
It goes from 100 million degrees Celsius to basically, 30 Celsius. Okay. And this distance, this is a person. So this distance is about 1 meter, if that. Now, as physics students, you probably know that there's one thing that nature does not like, and that's gradients. Nature doesn't like density gradients, Rayleigh-Taylor instability. Nature doesn't like...
Oh, and so I'm going to summarize his next point and then go ahead of here because he makes a great point. He says, nature doesn't like gradients. So this is actually a huge problem in plasma. Because if I have a really high temperature over here and a really low temperature over here, the hot wants to flow to the cold. Simple thermodynamics. So now if I'm modeling my plasma, now we have a problem, because now we have to take into account this thermal gradient and how that thermal gradient is going to move the plasma around just like a lava lamp. You heat up your lava lamp and now the plasma starts to flow all around, right? So now we have to take that into account as well. But what would be the answer for that? Isn't the answer for that so simple? The answer is we want lower temperatures. The lower the temperature that you can get that to be, the less you have to worry about the gradient. If there's a huge gradient, then that's a bigger issue for instability. So one answer would be, well, just try to find a way to get to lower temperatures and make your fusion happen, and then you have less of a gradient. There might be another answer, though, here. What's he about to say here? I think he says it somewhere around here.
Armor radius of an electron is this big, and these two turbulences happening at different scales talk to each other and inform each other. And you can see it here. You see, so these big blobs that you see are turbulence on the ion scales. But there's fine striations on top of each one of these blobs, and that's turbulence at the electron scales. And the fact that these two turbulences talk to each other means that if you want to get this right, you have to simulate all of these scales simultaneously. So to give you an example, for those of you who are interested in computational details, this simulation, this one simulation, the cost of it was 18 million CPU hours.
So this simulation that you're watching, 18 million CPU hours to do just this simulation where you're watching. Looks like my fake electric fireplace I've got over here. Looks like that. And this is what they're measuring. They're measuring this thermal gradient plus the electric conductivity in this plasma, and they're trying to figure out how the plasma is going to move around. That's what they're doing. And so you're realizing now as well, what else are we realizing? There is a direct connection between this plasma research and supercomputers, because you need supercomputers to model this plasma research. So if somebody has already got super advanced aneutronic fusion orbs, it means they also have supercomputers that go along with it, because they need the supercomputers at a minimum to model the simulations when they were developing them, but they probably also need the supercomputers to control the plasma in real time as well, to control it in real time, to do the math that's necessary to control the instabilities.
That means that if you have 18 million CPUs, you'd run them all in parallel for 1 hour to get this. Okay? That's not how it's done. This is run on tens of thousands of processors simultaneously. So parallel computing, right, state of the art then, and leads to this incredibly complex scenario that we then sort of mine for data and try to make better sense of. Now, it's not just turbulent tokamak plasmas that are turbulent. Space and astrophysical plasmas are almost invariably in a state of turbulence themselves, even if the reason for that turbulence tends to be different from just temperature gradients. And so this beautiful illustration that you can see in my virtual background is a simulation of turbulence done by my former student, Janadre in Chingulo, of turbulence in an accretion disk.
Okay, pop quiz hot shot. Pop quiz hot shot. If you don't know what movie that's from, get out right now, chat. Get out. If you don't know about Keanu Reeves, get out. Pop quiz hot shot. How do you battle against these turbulent instabilities? Right? So now we're looking at our plasma, and we've got plasma stuff mixing around every different direction. And we don't want that. How do we beat that, chat? Any thoughts out there? What do people think? What is a way that we can get around that? Do we see anything in the MH370 videos that might be able to be a clue as to how to deal with these turbulence instabilities? What about the fact that the orbs are spinning on their axis? When we're watching the orbs, we can see the heat signature, stable heat signature of an orange slice in the orbs. And we can see it spinning around. In some cases, it seems to flip. It seems to flip like this, but it also seems to spin around like this. What if the spinning is somehow able to stabilize the plasma itself? Almost like, you guys ever get cotton candy at the festival, carnival, or whatever? When they do the cotton candy, they spin it around, right? They spin it around, and then you got your cotton candy stick. Let's see if he gives us an interesting analogy right here.
Simulated using sort of an equivalent of the Boltzmann description. just to illustrate that complex turbulence like this abounds, you find it in fusion plasmas, you find it in astrophysical plasmas, and it's this turbulence that ends up setting the macroscopic properties of these media, right? So if I want to know how long it takes me to dissipate, to diffuse the temperature in this plasma, right? That diffusion is anomalous. It is set by the turbulence. It's not set by collisions of any means, okay? So that would be very, very small. The fact that this is turbulent means that your plasma is going to cool off much quicker than otherwise. Okay?
Here we go.
Incidentally, when you put a drop of milk in your coffee, you stir it so that you mix it faster, right? You're creating turbulence because that leads to faster mixing. Similar thing here, right? If you didn't stir, it would take a long time for that one drop of milk to turn your black coffee into gray coffee, right? So if you stir it, if you give it turbulence, it's so much faster. So same thing in a fusion device.
Stir it, chat. Stir it, and it gets everything to mix up faster. Holy shit. Holy shit. I did not think we were going to learn major things in this interview with this guy. I got to be honest. I thought I was going to watch this. Thought it was going to be a normie kind of fusion thing. Now I'm learning, oh, yeah, if you want to get your electrons and your ions to kind of stabilize, simplest way to do that without getting them to go out of control, to control their motion, just start spinning it. Spin it. Centripetal motion will overcome some of the stabilities, especially if it's a weak instability. Wow. I like this guy, chat. Okay. What's next?
Sheldon, of course, understands turbulent transport perfectly. So I put.
Oh, yeah. And he has a whole thing from Sheldon here. He even talks about how it works here. I think I'm going to skip that part, though. And then here he talks about the main issue that we discussed, which is here's the problem. The reason why one of the biggest drawbacks of our hot fusion reactors is they have walls. And so if at any moment you fail to confine the plasma, just like with the sun, you see these arcs shooting out of the sun and these coronal discharges coming from the sun. What happens in a fusion reactor? These discharges melt the walls. And he says right here that even after just 2 or 3 of these against the wall, you're going to melt the wall and the reactor is going to there's going to be instability in the reactor. Hull integrity at 22%.
Isn't the only instability that fusion plasmas have to contend with. There are, so as it happens, turbulence is sort of benign because, okay, so you lose temperature and particles and energy faster than you expect, but it doesn't lead to any major disruption of your fusion device. But you can also get sort of the tokamak equivalent of solar flares. And these are like macroscopic disruptions. So here's a filament that's about to be expelled from the plasma, very much like the solar flare that you saw at the beginning. And that launches a lot of particles, very fast particles that can then hit the walls of the device and do things like this. So this blob here, that's, those tiles have been melted by extremely fast electrons that were produced by the plasma. So this you cannot have, right? Because eventually, 2 more of these, you will actually pierce a hole through the wall. Right?
Wow. And keep in mind, guys, this was considered like the top plasma fusion, one of the top plasma fusion physicists in the world that we're listening to here. So this is about as cutting edge as you could get. And this is only from 3 or 4 years ago. So it's not even that old. 2021, I think. Yeah, 2021. Okay, let's skip ahead a little bit here. Inertial confinement fusion. Now, this is the form of fusion that they were doing with nuclear weapons. And what I think they've figured out is a combination. They took the magneto inertial confinement of plasma and the plasma orbs, and they combined it with inertial confinement fusion, collapsing on all sides. Listen very carefully to what he says about inertial confinement fusion here. I'm going to skip ahead just a little bit.
That creates X-rays, and then the pressure of those X-rays is supposed to make the target compress and generate enough pressure that you can fuse the contents. Okay?
So you produce X-rays. So basically the light, you shoot light on your object, causes X-rays to get produced. And then the X-rays zap onto your object, vaporizes the object, fuses the object. Boom, now you get your energy. That's the idea. The X-ray part is significant because we're literally looking at the X-rays in form of Bremslung radiation. I hope I'm saying that name right. I'll probably have to get Siri to tell me how you say it.
Now, does this work? Not yet. And it's easy to understand what might go wrong here. So here's a simulation. And, okay, so think you have a balloon, and now you have fingers trying to compress that balloon, right? And you know that if you compress here, the balloon will expand elsewhere, right? So what you try to do is to have many fingers compressing that balloon as uniformly as possible. Okay? And that's hard, right? To achieve that degree of symmetry so that you result in uniform compression rather than compression here, expansion there. That's a very difficult thing to do. So what you're seeing here is basically instabilities that are driven inside of this capsule by virtue of the fact that the irradiation by these lasers isn't actually uniform.
Holy shit, chat. Okay, anybody trying to gaslight me and tell me we're not looking at inertial confinement fusion, just get out. Get out right now. We're definitely looking at inertial confinement fusion here. He even specifically calls out the fact that the compression needs to be exact from all angles, right? Because you can imagine a balloon. If you're compressing a balloon and it wasn't exactly equal compression on all sides, you're going to get these instabilities where it shoots out. But if you compress it equally on all sides, especially if you compress it vertically like that, vertically, where is it going to go? It's going to either go forward or it's going to go backward, right? I'm compressing my object here. It's going to shoot out that way or it's going to shoot out that way. Those orbs are converging on that plane in a perfect equilateral triangle. Perfect compression. I can't even think of anything else that could be related to other than inertial confinement fusion. It has to be. It's the exact basis for inertial confinement fusion right there. So this is where I go, when you think about this and think about the science, you go, this isn't aliens. This is not aliens. Like, you can draw a direct map between when we figured this science out and how we were working on it. Magneto confinement fusion, inertial confinement fusion. And then we just took it to the next level, and now we're making nukes, but they're not really nukes anymore, are they? We're manipulating the atom, but we're doing it in a way that is a little bit more like Harry Potter at this point, or Star Trek.
So this is very much research in progress, as is magnetic confinement fusion, and it leads to all sorts of interesting physics that go beyond just looking at the actual fusion itself. And here's one of the interesting aspects of these laser plasma interactions, or laser target interactions.
This is really interesting, in my opinion.
So many times, what happens is when you shine a laser at a solid target. So in this case, the solid target would be sort of at the bottom of this blob here, of this green blob. So you shine the laser, you ionize the target, and you have an expanding cloud of material coming towards the laser. And then you have a temperature gradient, because if you're closer to the laser, you are hotter, right? And if you're further away, you're colder. But you also have a density gradient, because if you're closer to the surface, you are more dense. If you're further away, you're less dense. And as it happens, there's a battery mechanism that is generated by virtue of the fact that the temperature and the density gradients are not aligned. They can be perpendicular to each other. That's a battery that generates a magnetic field. And what you're seeing here is a simulation by Kevin Scheffler, who's a postdoc working with me some years ago, showing how when you set up that green blob, as it were, right, a blob of density with a temperature gradient that's perpendicular to the density gradient, you generate these magnetic fields like this. Okay, so
I gotta say, chat, this is one of the this part here, I didn't want to go too crazy on this, but when he explains this to me, yes, it almost sounds like a ZPE battery or some other type of monopole that's being created. He's saying that you can actually solve the temperature gradient that you're producing. Like, you're shooting a laser at something, you're actually creating a temperature gradient. Remember the difference in temperature? And so now you're going to have these relativistic effects where you're going to have hot trying to flow to cold, but you're also going to have this pressure counteracting that. And so what's going to end up happening at the end? What if what ends up happening is that you end up pushing something directly through space-time? What if you push it directly through space-time? This effect, he says, basically produces magnetic fields. produces magnetic fields just via this effect, just via this fusion, this inertial confinement fusion effect. This is about as close as I think he gets here to broaching an idea of the ether. And then he actually follows this up with the next thing he says here.
That's called the Biermann battery effect. And people do this routinely in laser plasma experiments, but it is also thought that this same mechanism, the Biermann battery, is responsible for generating speed magnetic fields throughout the universe. Maybe because you have a supernova explosion that drives a shock front, and at the shock front, you can have density and temperature gradients that are misaligned and generate magnetic fields.
So this is crazy. He's basically saying here, guys, if you're reading between the lines, he's saying that magnetic fields can arise from nothing. Magnetic fields can arise from the motion of matter throughout space-time. That we can just, magnetic fields can just spontaneously, potentially, appear and amplify. And to me, the question anybody should be wondering is, where's that energy coming from? How is that possible? From a classical view of an empty vacuum space-time, tell me where those magnetic fields are coming from, where all that energy is coming from. If it's not primordial, then how does it exist in a natural system?
Sort of the jumping slide where I go from talking about fusion to talking about magnetic fields in the universe.
Skip a little bit ahead here.
So here's a galaxy. This is M51. And this is supposed to be tracing the structure of the clusters themselves. That, like the conventional wisdom these days, is that magnetic fields themselves weren't really created at the Big Bang, right? So there has to be some sort of plasma-based mechanism by which you are going to create these magnetic fields, essentially from nothing.
Chat, someone clip that. There must be a plasma-based mechanism by which you're creating these magnetic fields essentially from nothing. Hold up. I had it. Hold on. I should have had it ready.
Imbalance.
Oh, wait. Is that even the right one? That wasn't even the right one. Boom! Gotcha, bitch. Gotcha. We gotcha, bitch. What do the 5 fingers say to the face? Slap. Give us that free damn energy. Give us that free damn energy. Everybody talks about there's no free energy. Well, my bro who just got assassinated says there's some free energy out there. Says the magnetic fields arise from plasma spontaneously. How about that? How about that?
And the Biermann battery that I just talked about is one possibility. You generate some sort of speed magnetic fields. And then you ask what happens to them as the plasma sort of moves and evolves these magnetic fields. So let's talk a little bit about that. So all of these environments, the Earth's core, the sun, solar system, the interstellar medium, galaxies, galactic clusters, they're all plasmas. You can think of all of these environments as plasmas. And so if you can think of them as plasmas, you might want to write down an equation for how a plasma evolves a magnetic field. And so I flashed this equation earlier. This is Ohm's law for a plasma. You might recognize it without this term. It just says electric field equals resistivity times current. You know, when you were in kindergarten, you saw voltage equals resistance times current, right? So this is sort of the differential version of that. This electric field equals resistivity times current. But of course, the plasma is moving. So what you have to do is you have to write down the electric field in the frame moving with the plasma, which is electric field in the laboratory frame plus U cross V.
So right there it was. When you ever hear the physicists say the magic word, frame, the plasma's moving in the frame. Whenever you hear them talk about the frame of reference, they're talking about general relativity. You live in your bubble. When I'm talking about you live in a bubble and you're experiencing things in your bubble and I'm experiencing things in my bubble and we're experiencing this shared reality between our bubbles converging, that's the frame of reference. My bubble is my frame of reference. Your bubble is your frame of reference. The plasma itself has its own frame of reference. Every particle in the plasma has its own frame of reference. That's where it starts to get weird when you start to calculate it, because now you have to calculate, well, what does this one particle see this other particle doing? And what if this particle sees this other particle moving faster than the speed of light? Now this particle is going to see this particle doing something that changes the physical effects. This is why relativity breaks everything. Relativity isn't the solution. So relativity is the problem. Relativity is the thing that breaks all of this stuff, that allows free energy to become real.
You combine this equation with Faraday's law. So you take the curl of this, and curl of E is minus the PdT, so you get the induction equation. So this equation tells me how the magnetic field will evolve in a plasma, subject to flows, plasma velocity U, plus resistive diffusion. Okay. So without this term, this is nothing but the diffusion equation, like the heat equation. But this term is quite interesting, and it gives rise to non-trivial behavior of the plasma, of the magnetic field in a plasma, and in particular, can lead to amplification of that.
Boom, baby. I mean, how many Yahtzee moments, chat? How many Yahtzee moments can lead to amplification of the magnetic field? He just talked about where are these magnetic fields even coming from? He says, it seems like these magnetic fields are coming from plasma from nowhere. If the magnetic fields are coming from nowhere, then clearly we can amplify them. And this is what Salvatore Pais has been trying to tell us. The secret of Salvatore Pais' patents is that they're not about aliens or UFOs at all. They're actually about fusion. Salvatore Pais' patents are actually about fusion and the cover-up of fusion and all of the technologies that fusion and fusion research leads to, which includes gravity manipulation. I'm going to switch gears and play a clip real quick. Why are they doing this? I think I already played this, but I want to play it again.
That if there are a group of people in the world that have access to it, I don't think they know how to let go of it because they're afraid who's going to get their hands on it. Even though there'd be tremendous benefit to mankind in getting us energy sources that we wouldn't have the problems we have with today, they're also worried about that somebody could take that same energy source and do the equivalent of what they did with the coal, of instead of blowing a hole inside, just obliterating the whole ship.
He's talking about the USS Cole there, actually. The subtitles are incorrect. The USS Cole. They're afraid of what somebody's going to do with this technology. Let me play one more clip. This is the Jason Giorgiani clip. I think we already played this, but it's just so significant in the context here. What is aneutronic fusion doing? And that last point was the biggest point that Nuno Loureiro made, which was that if the magnetic fields are coming from nowhere, where are they coming from? You know the answer. The answer is the 0-point energy. The answer is the ether. That's where the magnetic fields are coming from. And what it means is that if the magnetic fields can come from nowhere, there must be a reservoir of energy. The exact thing that we've been saying. And that would mean that fusion has a direct connection to 0-point energy. It's tapping into 0-point energy. The same way that an oil well taps into the oil underneath the earth that we don't see, but it's there.
Nuclear plasma fusion, which doesn't need to be ignited by a fission trigger. That's how our fusion bombs work. Our fusion bombs are a nuclear bomb, an atom bomb goes off, and it then creates a secondary fusion detonation. Right. That produces fallout. The fallout comes from the fission trigger in a fusion bomb. If you could create a pure fusion explosion, it would be non-radioactive. There would be no fallout, which is an incredibly useful nuclear bomb, because if you have forces waiting to occupy an area that's just been nuked, they don't have to worry about the radiation. They can move in right away and secure the site, right? Mm-hmm. But here's the other thing about it is that what they discovered, and this is why the technology was never released to the Argentine people.
Here we go.
In these liter and half-liter containers that Perón was bragging about, is that this plasma fusion warps space-time locally.
It warps space-time locally. We're going to find out. The biggest Yahtzee moment of them all will be when we find out that fusion is not just a simple chemical reaction, that fusion, due to its electromagnetic nature of plasma, is directly interacting with 0-point energy. It's directly interacting with 0-point energy and therefore manipulating space-time, because 0-point energy is space-time. That it's essentially a tap into space-time and into an energy source that we have currently been ignoring. And that we can pull that energy out. This is probably the most important part. Aneutronic fusion means that we can pull that energy out in the form of electricity, which means no converting into heat and then converting it back into electricity. That we can tap into that energy and pull it out already in the form of electricity, which is already usable for us. That's going to be the big reveal. And that's, in my opinion, why we have not gotten fusion in 60 years. Because they've known that behind the scenes, and they've known that once that cat's out of the bag, there's no putting it back in. Once Pandora's box is open and everybody knows that fusion produces excess energy, why would anybody focus on anything else? Right? Why would you? You've now known that everything else is obsolete. Okay, so let's get back to the last bits of this. So energy amplification. So now this was the part that I posted because I thought this was the thing that made the most sense for normies out there, which is understanding why this is significant just using basic math. Now, I argued with people months ago about the age of the sun. I said there's no way that the sun is only, 4 billion years old or whatever the heck we think. We're going to find out that stars are a lot more stable than what we would have predicted. And people go, no, the math all adds up. It's just burning off, hundreds of millions of pounds or whatever tons of fuel every minute. Right? Because you would think, hey, if that's a fusion reactor up there, that thing should burn out pretty quickly. But it doesn't. It doesn't ever burn out. So even if you discount that, even if you say, no, we can explain the sun, it's burning up the fuel, and the fuel's being slowly used up, and once the fuel gets used up, it's going to explode. The Earth is a bigger problem. Because at the center of the Earth is supposedly a molten iron core. But the problem is that molten iron core should cool down eventually over time. It should cool down over time, and it should definitely lose its magnetic field over time. It may take a really long time, but it should still happen. The same way where if I put a magnet on my fridge, yeah, it might last for 20 years, but eventually the magnet's going to fall off the fridge. And so here he is explaining this particular problem. Again, this is one of, if not the top academic fusion scientist who was just assassinated.
Let me ask the organizers, how long should I speak for? Do I have another 5 minutes estimate? Let's just have a magnetic field present when Earth formed. Now you think that the outer core of the Earth is an MHD fluid, it's a plasma, okay? And we know what its properties are. So you know that based on the properties of that fluid, if you have a magnetic field present when Earth was formed, it would take about 10 to the 5 years for that field to ohmically diffuse. But we know from paleomagnetism, so essentially measures of the magnetic field on Earth, that the Earth has had basically a constant magnetic field for essentially however long it's existed, around 10 to the 9 years. So you conclude from this that the only possibility is if the Earth actively generates its own magnetic field. Right? So the motions of the core of the Earth are such that via the induction term, they continuously generate the magnetic field of the Earth so that this term cannot just dissipate it away.
I mean, holy shit. How are more people not talking about this? Is this commonly accepted? I actually don't know, because if I'm somebody who's trying to look for an answer for why physics is broken and doesn't make any sense, well, there you go. You just gave me the best possible evidence I could ever hope for. Turns out that the motion of the magnet of the core of the Earth, of whatever's in the center of the Earth, is actively producing magnetic fields that mean that the Earth's magnetic field is not weakening. at least not weakening as much as it should be, dissipating as much as it should be. So from that perspective, I would say, okay, wow. This means that there must be some system that we are not familiar with that is replenishing energy. Where is all this energy coming from? Because something has to be getting used up. If this isn't the case, is the Earth slowing down? What is getting used up that's allowing for this energy? And so this is what I think is such a, these are my favorite things in physics. Because these demand answers, experimental views and results, math that can't be denied. And it's not even close. It's like we expect 10 to the 5 is how long the magnetic fields would last. But it's lasted for 10 to the 9. 4 more zeros worth of time that it's lasted. And it's not weakening. It doesn't seem to be weakening, which we can tell because we can look at iron samples and core samples. Very interesting.
And that's sort of a demonstration of the need for a dynamo on Earth. But it's similar for the sun and similar for many other magnetized planets and stars. More recently, we're trying to go beyond this MHD description of dynamo and actually look at dynamo in collisionless plasmas. And that's very complicated.
So dynamo, I haven't fully dug into the dynamo aspect, but my understanding of dynamo effect is like things just spontaneously flipping. And if this is accurate, then he might actually be giving more evidence and weight to the idea of the magnetic pole reversal. In fact, because what he's saying here is that you might have this buildup of magnetic fields, which leads to a situation that causes the entire core to flip suddenly, right? Suddenly just flip. And then the question is, well, what would be the impact of that? Is that actually going to cause a cataclysm on the surface of the planet? Or will we just not even notice at all? And that's the Chan Thomas story. If you're not familiar with it, I think we reviewed that like a little over a year ago. Or you can just follow, what is it, Sunweather Man or whatever those guys are. I'm not a big fan of that because if there's going to be a cataclysm, what do I care? I can't do anything about it. What do you want me to do if there's a cataclysm? You want me to go break in Mark Zuckerberg's bunker? Like, come on, guys. What are we going to do? We're cooked. We're cooked. Okay. Last thing I want to go to and point out is the first question that he gets asked. So this was pretty much the end of the presentation. He talks about the dynamo effect a little bit here. And then he does his summary about why plasma physics and research is so awesome, which I agree. And even says supercomputing has been one of the pillars of plasma science. Dawn of the new era with exascale machine learning and quantum computing. Is it the dawn of a new era? I would say yes, absolutely. And so he gets asked a question. Where does he get asked it? I think, let me see here. Where does he get asked this question? I think it's okay, here.
Well spotted.
The very first question right here.
Maxwell equations. It's simple, and it was on slide 6 when you present the Maxwell equations. I was wondering why do you not? Why there wasn't the displacement current on the J on the fourth equation?
Spotted.
He gets a question about displacement current. Now, I think, is JK Philly fan in here or not? I can't remember if back EMF is the same as displacement current, but I remember there being some controversy over displacement current. So let's listen to see what he says about the fact that he doesn't see the displacement current in the equations. This is one of the students.
Well spotted, people. You get kudos for paying attention. Well done. I didn't write the displacement current because I was focusing on the sub-relativistic limit. And so if you are at velocities that are much smaller than the speed of light, that term is small. Okay, so you don't need it. But if I was worried about relativistic effects, I would have to keep it. So that's the answer.
If I was worried about relativistic effects, I would have had to keep the displacement current. Wow. Well, hey, chat, what are the topics of Ashton's live streams? How about relativistic free electron X-ray laser as being one of them? So I'm going to go ahead and say we do have to worry about the displacement current, and we do have to worry about relativistic effects. We definitely do. In fact, that's exactly what they're abusing to make fusion work. People want to wonder, if you want to know, why is there this huge disconnect between academia academia that thinks that fusion is not possible, that it's 20, 30 years off, what have you, and the Black Project world, where they have all this technology. The difference is academia is simplifying everything. Academia is saying we're going to ignore relativistic effects. And the Black Project world is saying we're not ignoring relativistic effects, we're including them. The relativistic effects are the Harry Potter magic. That's where you find the negative energy. That's where you find all the cheat codes, is in the relativistic effects. You will discard those. Hell no, we're not discarding those. That's the magic. That's the magic. So when we look at all these effects, these are the very things that the engineers are talking about. So tonight's moment of Zen, in that vein, is the BPTG. The BPTG. People are going, what's BPTG? Y'all know. The Black Project Throat Goat, chat. The Black Project Throat Goat. At the time, I knew this clip was important, but I didn't really understand why it was so important. I knew it was important because coherent matter wave beam reminds me of turning matter into a wave and getting it to line up. And that's exactly what I would expect we would want for a fusion reactor. I want my matter and my fusion reactor to line up. I want it to be confined in my magnetic fields. I want it to be very close. And I want to abuse relativistic effects like vibration to get it to overlap and come together and fuse together. That's the basis for fusion, using vibration. So here you go. The BPTG, chat. Charles Chase. Coherent matter wave beam. Let's listen very carefully.
Is a coherent matter wave. What is a coherent matter wave generator, and what led you to develop this?
Yeah, so I have that patent along with my colleague, Dr. Mo Arman, who was a brilliant Iranian scientist too.
Wait, what? Did he just say that his counterpart was a brilliant Iranian scientist, Mo Arman? And I do have to say, I just have to repeat that there was a story that Iran supposedly assassinated this nuclear scientist right now. Do you want to point that? This actually isn't even the clip. This is actually a different clip of Charles Chase explaining the same thing. The clip that I did want to play, we might go back to that clip in a second. This was the clip that I wanted to play.
Something my colleague, Dr. Mo Arman, and myself, is really Mo's idea, but I helped him with that. This is a way of generating matter wave beams. So rather than a laser beam, it's a matter beam with fermions. And we're using our Harnaff bomb effect to put things, fermions, in coherence, which sounds like, wow, that doesn't sound like that would work. Because there's you can modify the fermions with no energy exchange. And so we predict that we'll be able to put those incoherent and generate a beam. And people have done those with Bose-Einstein condensates, at very low temperature. But using one of those constraints, Lorentz invariance, well, that fermion condensate is a beam in a different reference frame. So in my mind, that shows you can build a beam out of fermions.
So right there, he says it, frame. He says the key word, frame. The frame of reference. Whenever you hear people talking about the frame, they're talking about Einstein's general relativistic effects. What Charles Chase is saying here is that we can abuse general relativistic effects, and now we can make a beam of matter, we can make a laser beam out of matter, where now previously the matter would never have been able to hold the same point like a laser does, but now we can make the matter in the same exact location. You would say, Ashton, that's impossible. You can't have two things in the same location. And Charles Chase is telling you with general relativity, you can. You can. It's straight up magic.
A million times more powerful than a laser, plus atomic scale manufacturing and maybe transport of matter over a distance.
Maybe transport of matter over a distance. Oh, and by the way, we're going to be able to make Star Trek replicators with that technology, because we will literally be able to make a 3D printer that is printing your object one atom at a time. One atom at a time, printing your object up. Can you imagine that? That's the world that we live in. Rest in peace to the quiet goat. Nuno Loureiro. Oh, man, butchering that last name. Rest in peace. I hope that we find justice for you. I will be looking and monitoring this situation for updates. So far, there are no suspects whatsoever. There's nothing related to it. We're not going to let this guy's death be in vain. We will help to find out who killed him, why they did so. So look out for more updates on my Twitter feed or on the live streams. Let's do the super chats. Tracy Scott, thank you so much for that super chat. Appreciate you, brother. Jaleel Robinson says, Ashton, let's say all of the free energy technology has been suppressed for the last century were to be released tomorrow. Where do you think our species would be on the Kardashev scale in 10 years? We would have to come up with an entirely new scale. That's how crazy this is. And it goes to show how far off the physicists have been. This level of technology, this energy source, basically jumps us up to Kardashev scale 2 or 3 from 0. From 0. We move up several echelons in the tier. And this is why people don't really understand the implications of this technology and why they've been suppressing it. Is we're not talking about a linear growth, not even an exponential growth of technology. We're talking about we're breaking the wheel. The old ways are done and gone. And now we have to come up with the new ways, including living with AI, not having to work anymore, potentially people living forever. We've got a whole new slew of problems that come along with this. So we're going to need an entirely new Kardashev scale because what's going to happen doesn't even rank on that scale. It doesn't even accommodate it. Thank you very much for Mick Leonard for that super chat. And Zapparoo, thank you very much for that. Could the lithium-ion batteries create an ionized gas or plasma core that amplify the field's rotation? I think that, I don't know if this is exactly what's happening in the orbs, but I think that that's what the batteries, whatever was in the batteries, if it's lithium or some other catalyst, I presume it's lithium, they wanted that to burn so that the gas would expand and so they could use that gas as part of the process of zapping the plane. Truthfully, that's what I believe makes the most sense, but I'm open to any theory. If it turns out that they don't need the batteries at all to teleport things and that the orbs can do that themselves just via magnetic reconnection, fine. Not quite at that level where I can look at 2 videos and figure out the exact math that's happening from thermonuclear detonations just yet, but don't rule it out. I didn't think we would get this far where we're at right now. So, and then Timothy Foster says, heads up, bro. MIT professor researching fusion was just murdered. Just saw the post. Watch your 6, bro. I mean, this is what the whole stream's been about, guys. And yes, everybody's been pinging me about it. I don't care if anything were to happen to me. If anything were to happen to me, I would want you guys to do what we did here tonight. Celebration of knowledge, the opposite of a celebration of ignorance. Celebrate knowledge, share knowledge, learn something new. That's what I leave with you guys tonight. Have a great night, guys. Wednesday, I've got a bunch of great content for Wednesday. We're going to talk about quantum mechanics on Wednesday, and we're probably going to talk about some warp drives. I got Travis Taylor, and I've also got PBS Space-Time up. We're going to dig in through the history of quantum mechanics, and I'm going to tell you exactly where quantum mechanics went wrong. It's going to be great. Check it out on Friday, guys. Peace out. Thank you, everybody in the Pill chat. Thank you, everybody in Rumble chat. And thank you all in the YouTube, guys. Big shout out to Bob Greenier, who's been on the front lines for a really long time, guys. Make sure you're following the Martin Fleischmann Memorial Project if you do not. Later, everybody.
Out in the fields where the skies are wide. Talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space. Traversable paths to a far-off place. No black holes pull, no crushing weight. Just a cosmic tunnel to a distant gate. Talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum, squeeze so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course. Talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. Thin shell formalism plates so fine. Spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plate, creating the throat, open the gates, from Earth to the stars in a single bound, a shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread. Talking wormholes, stargates, negative energy. Travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our path is clear. Exploring the cosmos.